Good afternoon, everyone. Welcome to the second webinar in this series of webinars about the Cyber Resilience Act, part of the CRACY project. My name is Wiebe van den Driessen. I am a PhD researcher at IMEC Ghent University. And today I will talk about SBOMs and why they are so important for the Cyber Resilience Act. So I will talk about what is an SBOM, how you can use an SBOM, why they are so useful for the CRA, how you can generate them, how you can trust them, and finally I will give a short overview of the current tooling ecosystem with some good tools you can use yourself. So what is an SBOM? SBOM stands for Software Bill of Materials and is a nested inventory of software components in a machine-readable format, XML or JSON, following a specific specification, which can be CycloneDX or SPDX. And they are used to track software elements, and you can identify vulnerabilities with them, and thus mitigate security risks. Here's a simple example of how an SBOM can look in JSON. Specifically CycloneDX. And CycloneDX is a specification that I will explain a bit more in the next slide. You see, for example, that it starts with specifying the format and specification. It has a serial number, version, metadata, and then a whole list of components inside the bill of materials. I will not cover the full structure of CycloneDX specification or the other SPDX specification, but I will give you a short comparison which reflects a bit in my opinion, on both specifications and which one you should use. So on the left we have CycloneDX, on the right we have SPDX. CycloneDX is started out with the XML and JSON format and is more recent than SPDX. SPDX had started out with its own format, but now also support the other formats like XML and JSON. CycloneDX is newer and sees a faster tooling growth, while SPDX is more mature, is an ISO standard, and has seen slower JSON adoption, but now also fully supports JSON. So everything in CycloneDX is structured as a component, which is a bit more forgiving for errors than the SPDX specification, which requires more specific type distinctions and is a bit easier to break, in my opinion. CycloneDX also has the advantage to use package URL, which is an identifier for packages that you can use across different environments and ecosystems. And CycloneDX also started to reach beyond software and also provide bill of materials for other things like hardware and machine learning. CycloneDX was primarily built for vulnerabilities and vulnerability handling, while SPDX was primarily built for license compliance. But I have to say both specifications can more or less do both use cases at the moment. But if you are looking to specifically do vulnerability handling, I recommend using CycloneDX. CycloneDX has a little bit more tooling than SPDX. But SPDX has come with a new version 3.0, which improved a lot and is leaning more towards a CycloneDX style of defining its specification. So in this case, with the Cyber Resilience Act and the need for vulnerability handling, in my opinion, CycloneDX would be a better pick. And of course, we need a lot of tooling to do things with these SBOMs. And we can categorize the tooling into different abilities. We need tools to generate these SBOMs. That's the most important clause, because you don't want to build them by hand, of course. You want to automatically generate them while you build your software or after you build your software. But we also need tools to validate them. So we need to check if the fields of the BOM are actually correct for a given specification, if they comply with CycloneDX, for example. and also validate, for example, JSON structure, and optionally verify even a digital signature. We need to be able to edit these bill of materials. We need to change or update fields. So tooling for editing is also necessary. We have tools that allow you to compare different bill of materials. And then another large important class is the consume category class. We need way more tools in this category. It needs to be at least bigger than the generate tooling class. And the examples of consume tooling can, for example, be JSON viewers or vulnerability scanners that use bill of materials, license checkers, and even important compliance checkers. Then we have tools to also merge multiple bill of materials. And of course, we have tools to convert bill of materials from one specification to another. Because SPDX and CycloneDX are more and more growing to each other, it's more and more easier to convert an SPDX document into a CycloneDX document. And finally, a small but very important category are the tools to sign these bill of materials. We need to be able to sign them to prove authenticity and integrity of the bill of materials. More on that later in the slides. I also recommend taking a look at the URL at the bottom, which is a cool website to basically get an overview of all the current software bill of materials tooling. Now we will take a look into how we use those SBOMs and what are the main use cases. So there are two main use cases. The first one obviously being vulnerability detection. So we need to identify security risk and dependencies. A good tool for that is Gripe. Later in the ecosystem overview, I will talk more about these tools. And this is good for the CRA because it enables proactive risk management and, of course, vulnerability reporting. And vulnerability detection is, like I said earlier, best done with the CycloneDX specification because it's specifically built for that purpose. And the next category is license compliance. We can also do license compliance handling with these bill of materials. We can detect incompatible or risky licenses. And we can use tools for that like Grant. And this is best done with the SPDX specification because it's specifically built for doing license detection. Now, of course, the main overlapping use case and the reason that you are probably here is for legal compliance, specifically the Cyber Resilience Act. So we can use these BOMs and vulnerability detection to comply with the CRA. And also important for context is that I provide you with some definitions and standards that are often used when scanning and reporting these vulnerabilities. First, we have a CVE, which is a common vulnerability and exposure entry. So this is basically a public identifier that describes a specific vulnerability. We also have a BOV, a bill of vulnerabilities, and it's simply a list of all the vulnerabilities that affect a specific software product. So think of it as the raw output of a vulnerability scanner. But then you have something called a VEX document, which is a vulnerability exploitable exchange document. And this document declares whether the product is actually affected by the listed CVE. So it helps you reduce the false positives from a vulnerability scanner by giving a formal statement of the exploitability status of a certain CVE. So on the right diagram, you can see a more simplified version. And in reality, there is more than two statuses, save and alert. You have a bit more than that. But these VEX documents are also defined in the CycloneDX specification, for example, as well as a VDR, which is a vulnerability disclosure report. It is a generated report that contains full details about a vulnerability and also the plans to address the specific vulnerability. There's also a CycloneDX specification to set up this document, but you can also do this handwritten. And this document specifically can fit well as an internal report that serves as part of a certain coordinated vulnerability disclosure process. Now we will finally take a closer look to the Cyber Resilience Act itself, and we will see what it actually says about the software bill of materials and about vulnerability reporting. So I will give you an overview of sections in the CRA that mention SBOMs and give you a brief description of what is said. So in the obligations of manufacturers, which is Article 13, we can find that manufacturers must provide the software bill of materials upon request to market surveillance authorities. So market surveillance authorities are the national authorities that check whether manufacturers comply with EU product rules. And then more specifically in the essential cybersecurity requirements in Annex 1, it states that manufacturers must prepare these SBOMs in a machine-readable format that includes at least the top-level dependencies. Thus, we are actually are there problems with the sound? I see that Nikos has an issue with the sound. I don't know if I'm clearly understand, if you clearly understand me or not. Can someone maybe confirm in the chat? No issue. Okay, I'll continue with the presentation then. In Annex 2, which is the information to the user, it states that if a manufacturer chooses to make an SBOM available to users, they also must state where the SBOM can be accessed. And in the technical documentation requirements, it states that kind of the same thing, that it must include an SBOM as part of a vulnerability handling process, and that market surveillance authorities may request the SBOM when necessary to verify compliance with essential cybersecurity requirements, which is kind of straightforward. And then in the recital 77, the CRA requires the creation and availability of an SBOM, but does not mandate its public disclosure. So it's not, you don't need to make your SBOM public to everyone. And then I will give you a similar overview, but for mentions of vulnerability handling requirements, because there's also a lot of that in the CRA. Article 13, the obligations of manufacturers, states that manufacturers must have vulnerability handling processes, including CVD policies. And in the essential cybersecurity requirements, it also says that manufacturers must maintain and enforce a coordinated vulnerability disclosure policy. So what's that CVD? A coordinated vulnerability disclosure policy is basically the document that explains how external parties and users of a software product can report a vulnerability to the manufacturer, and also defines how the manufacturer can handle them. And then Annex 2, information to the user. It states that your product documentation must include the vulnerability reporting contact point and where the CVD policy is available. So there needs to be some sort of contact point that users can use to report their vulnerabilities. Same thing for the technical documentation, needs to contain the same things, and also a description of secure update mechanisms. And then Article 16 is the establishment of a single reporting platform. So the CSIRTS, which is the National Computer Security Incident Response Team, disseminate these vulnerability notifications through the single reporting platform. And that is the EU system that they use to share vulnerability notifications. It is part of the broader network of coordinated vulnerability management. This dissemination can also be delayed if it's justified, for example, if a CVD is still ongoing. Then finally, in recital 70, it states that they may partially disclose or delay information for national interest or cybersecurity reasons. So now we will take a short look in the techniques that are used to generate the software bill of materials. And there are basically two main techniques used. but in reality there are of course more. But the main ideas are first, when we generate a software bill of materials from artifacts, that's the first one, we work directly with binaries, with compiled libraries, with container images, or other build outputs. Very important is the build output. So the accuracy of this method depends heavily on the metadata that is embedded inside the artifact. So for example, for static binary languages, such as Rust or Go, they often produce a single binary blob with very limited metadata, which reduces the amount of information we can extract. So it will be more difficult to extract the dependencies from the artifact and put them in a bill of materials. And then we have the managed ecosystem languages, such as Java or .NET. They usually retain rich metadata. So for example, an Uber jar file still contains dependency information. So for those languages, it will be easier to extract the dependencies for certain tools. So we can conclude that techniques like obfuscation, symbol stripping, or aggressive optimizations reduce what remains visible in the final compiled binary artifact. So this method reflects exactly what is shipped, but it does not capture any build context. And that's why there's also a second method or technique, which is to generate the bill of materials also from the source. And then we rely on manifest log files, build configurations, and basically the overall code base before or during the build of a software product. And those tools are called software component analysis tools, and they basically read the package managers and the project metadata directly in the code base. And this gives us a view of all intended dependencies with high completeness. So in contrast to the first method, this one will list also dependencies that are, for example, imported, but not actually used. And it also includes build context that we would not see if we only looked at the final artifacts. But a limitation is that only source-based SBOMs do not include binary hashes unless we pair them with the build output. And this makes them ideal. All this makes them ideal for early vulnerability analysis. And most modern SBOM tooling therefore combines both artifact-based, source-based, but also other techniques to create a rich as possible software bill of materials. And then a very important part is that you need to embed this creation of this SBOM in your CI/CD pipeline. This makes it part of a security-first development workflow. Marleen Seebrachts already talked about this in the first webinar about DevSecOps, the DevSecOps life cycle. So we basically create a pipeline that builds the software, generates automatically the software bill of materials using tools, and then signs and/or attests the SBOM to record who created it, what it contains, and how it was produced. And then the SBOM is published next to the build artifacts. And this results in fully reproducible, traceable builds, continuous assurance and compliance, and you will gain automated vulnerability management. But how can we trust this software bill of materials? How can we have guarantees to these bill of materials that it's correct? So when we generate an SBOM, it's not enough to just list the components. We also need to actually trust it. We need to be confident that the SBOM hasn't been tampered with and that it truly corresponds to the software build it claims to describe. So two questions arise. How do we know the SBOM is authentic? And how do we link the SBOM to the actual build environment so we can trace it back to the specific build? The answer is to sign the SBOM and record its provenance. And how do we do that in practice? Well, in the pipeline, you will sign the SBOM. You can do that with tools like cosign, sign blob. And then you bind the digest, and then you will get a cosign bundle. You can log that transparently on a tool called Wrecker. You store the artifact immutably. For example, you can use GitHub Artifact for that, or an OCI registry. And then it's important to often verify your own software bill of materials. You can do that also automatically in the CI/CD pipeline or at deployments. Finally, we will take a look at the current SBOM tooling ecosystem. I will show you a couple tools that I think are the most interesting to get started. Of course, there are many more, but I will be focusing on the open source tooling that you can immediately use for your own software. So first, the overview. You can see that CycloneDX has a bit more tools than SPDX. And again, I added the URL to the SBOM catalog page, which I highly recommend to check out yourself. So first, when looking at the CycloneDX ecosystem, they not only have the specifications, but also provide a very broad set of tools. CDXGen is one of the most widely used tools. It can generate a CycloneDX BOM for many different languages and can integrate with OWASP DepScan for vulnerability analysis. It's a very good combination, these two tools. CycloneDX also has a command line tool, which focuses on manipulating existing BOMs, for example, transforming formats from CycloneDX to SPDX, or validating files, updating certain fields. And beyond that, CycloneDX also provides official plugins for a whole range of programming languages. So it's a very large ecosystem that continues to grow, and the main GitHub organization hosts a dozen of supporting tools and libraries. You can check it out yourself at github.com/CycloneDX. And then we have Anchor. Anchor provides a strong set of tools for SBOM and vulnerability workflows. You have SIFT, which generates SBOMs for many ecosystems. You have Gripe that focuses on scanning vulnerabilities. You have Grunt that scans licenses. And all these tools are open source. And they are widely adopted because they integrate very well with CI/CD pipelines and container workflows. And Anchor also offers a proprietary SaaS platform for enterprise users. For container-based scanning, several tools stand out. Trivy is an all-in-one solution that performs vulnerability scanning and also has support for SBOMs. It's also open source, very commonly used in container pipelines. Then we have Turn, which focuses on producing SBOMs from these container images by inspecting different layer contents, also open source. We also have Kubernetes BOM, which is another SBOM generator originally developed inside the Kubernetes project itself, but now it's a standalone tool you can use independently as well. It's also open source. And finally, we also have Docker's out-of-the-box built-in SBOM feature. So not a lot of people know that you can actually type Docker SBOM already out of the box, and this will call SIFT actually behind the scenes. SIFT can also scan containers and will generate an SBOM for your Docker container. And then for establishing the trust and provenance I talked about, Sigstore provides the core set of tools. We have Cosign, which is a tool used to sign the artifacts, including the SBOMs. We have Record, the metadata ledger, which is a transparent append-only ledger. And then we have Fulcio, which is which issues short-lived certificates to support keyless signing. And then we also have some other tools which are not important for SBOM signing. And all of these tools are also open source under Apache 2. Also a notable mention is the InTotal framework, which complements Sigstore by providing a framework for supply chain integrity. So it defines attestations across the whole supply chain pipeline. And it defines attestations that describe each step in a build or release process and is widely used in modern provenance systems. It's also open source. And then in the broader SBOM landscape, SPDX is the other major specification, of course, but compared to CycloneDX, it has fewer generator tools, but there are Maven and Gradle plugins. And there are libraries to work with SPDX files. Quack is another emerging toolchain. It aggregates SBOMs, VEX documents, and other supply chain metadata into a high-fidelity graph database. It is part of the OpenSSF incubating projects and is open source under Apache 2. The support for all kinds of these input documents will make it a very powerful platform for consolidating like all the data you have of your supply chain and vulnerabilities. So we have come to the end of the presentation. And so what are the main lessons we learned and what are the best practices? We learned that no single tool fits all environments and fills in all metadata. You have to experiment with these different tools and find the tool that is best fit for your specific use case. You need to embed these software bill of materials into your CI/CD pipelines and sign them. Try to validate, edit, merge SBOMs so you really get used to working with them. It's also important to regularly scan for the vulnerabilities and license conflicts and try to generate a VEX document or a VDR document on your own. It can be very useful for complying with the CRA later on. So align processes with the Cyber Resilience Act transparency requirements. If you want some hands-on practice, we have a very good GitHub workshop you can do on your own at home. You just need to fork the repository and follow the README at IDLab-DISCOVER/SBOM workshop. I highly recommend trying this out. CycloneDX started as a specification focused purely on software, but it has evolved well beyond that. It now supports hardware, services, operation bombs, machine learning bombs, and a lot more. But also SPDX is following the same trend and moving beyond software, so it's also important to note that. So then for the next webinar will be the role of cloud security in CRA compliance for SMEs. This will be in March. I will send you an email with the registration page later, and more information on the CRA you can find at the CRACY website. So we have come to the end. I hope it was useful for all of you. If you have any questions, you can put them in the Q&A or in the chat. And then I will try to answer them. And I hope you all have a good weekend. I'll wait a few minutes for if there are any questions. Diana, thank you for attending. So no questions, then I will end the meeting. Thank you all for listening and participating. And I hope I will see you in the next webinar in March. Have a good weekend.